So till in the last session we have studied the AND gate, OR gate and NAND gate. So in last session also we have studied regarding the basics and as well as the Boolean functions. So we know the Boolean function will consisting the constant and variable values. It may be 0 or it may be 1. Okay. So AND gate, the function of, and how we'll write the Boolean function, that is f into bracket a plus b bar. Okay, so this is a Boolean function, that is f of a plus b bar into bracket c, or else we can write it as f into bracket a comma b comma c. It equals to a plus b bar into c. So the values of these a, b, c, it may be 1 or it may be a 0. So next gate we'll study, that is XOR gate. So XOR gate, we'll call it as exclusive OR gate. So symbol of OR gate. This is a symbol of OR gate. If you put like this, then it will become a XOR gate. So this is also having a 2 inputs and 1 output. Okay. So the function of this XOR gate, it is what? Q is equals to A plus B is your OR gate. Correct. So if you put a circle like this, then it is a plus B. This is XOR gate. So for truth table for XOR gate, it is same values will take, that is 0 and 0. This is 0, 1, 1, 0, 1, 1. We'll see the expressions for. How we'll read this? We'll read it as A or B, A or B, but not both gives the Q value as odd number. So whatever these values of A and B, these are the combination of OR gate. But these both value gives the Boolean function as in the form of odd. Or else you can say it will give the expression in the form of odd number. So we'll see. If both the values are 0, 0, so it will be a 0 plus 0. It will be a 0. Yes. So next is 0 plus 1. Correct. So 0 plus 1 is what it will be? 1. So 1 plus 0. What it will become? 1. If both the inputs are on, already we have said it is a combination of OR gate, but both values will not give the even number. It will give the odd number. So if we do the 1 plus 1, so as I said in the OR gate, it will become a 2, but it will not give the even number. It will give the odd number. Yes, and it is not having any 2 inputs. It is having only 1 input. Correct. So if both the inputs are on, that is 1 and 1, both A and B are on, then the Boolean expression is 0. So this is a XOR gate. This is a combination of OR gate. So till now we have studied regarding the AND gate, OR gate, NAND gate and XOR gate. So AND gate is a combination of NAND gate and what you can say OR gate. OR gate is a combination of XOR gate. So till now we have studied the 4 gates. Those are AND gate, OR gate, NAND gate and XOR gate, that is exclusive gate. So next gate is what we'll say. Okay, so next gate is XNOR. So this is X this is XNOR. You can call it as exclusive NOR gate, not NOR gate. So in short form, what we'll call it as XNOR gate. So XNOR gate. This is also combination of OR gate. We'll see the. It's also having the 2 inputs and 1 output. But XNOR gate, before this XNOR gate, we will study the NOR gate. So NOR gate is, symbol will represent the NOR gate is same thing as XOR, that is A comma B. It may be greater than or equal to 1. This NOR gate is. So we'll see the truth table for the NOR gate, that is B and A. Same inputs will apply 1 1. But the expression for the NOR gate is Q was equals to A bar plus B bar. Okay. So what we'll get as A bar plus B bar. Yes, Q is equals to A bar plus B bar. Then what we'll get, that is 0 plus 0. So A bar plus B bar is nothing but A plus B bar. Is it? A plus B whole bar. Correct. So 0 plus 0, what will get? 0. 0 bar of this is, what will get? 1. So next is 0 plus 1. So it will become what? 0 plus 1 is 1. So bar of 1 is what? It will be 0. So next is 1 plus 0. So it will become 1. So bar of 1 is 0. So next is what? Both the inputs are on. Correct. But it will be 1 plus 1. What will take? 1 will take usually. So bar of 1 is 0. So this combination of this NOR gate is your XNOR gate. So combination of OR gate was XOR gate and the combination of NOR gate is XNOR gate, that is exclusive NOR gate. So this is a symbol of this exclusive NOR gate. So this is Boolean expression is Q. Okay. So next what it is? Truth table. So truth table for XOR gate, XNOR gate. That is 2 inputs and 1 output. Same inputs will apply. So the function of this exclusive NOR gate is what? You can say it as Q is equals to A plus B whole bar. So this is a function of X NOR gate. So for truth table we'll see that is first one is what we are giving, both the 0 0. But 0 plus 0 is 0, so bar of 0 is 1. So this is a bar. So Q is equals to 0 plus 1. So it will become 1. So bar of 1 is what? It will become 0. So next is what? 1 plus what? Can say one plus 0 will say it will become 0. So bar of 1 plus 1 is 1, bar of 1 is 0. So when both the inputs are on, so 1 plus 1 is, as I said, it is so 1 plus 1 is 1. This is when both the inputs are on in the XOR gate, it will become 0, not 1. It will become 1, not 0, sorry. So the XNOR is 1 0 0 1. So next is NOT gate. Okay. So in the NOT gate it is inverter, you can say. So this NOT gate will come under the single input logic gates. Under that the hex buffer is there. So before we go to this NOT gate, we'll study the single input logic gates. So that is the representation of the single input logic gate under that hex buffer. So it will be always one input, one output. So the truth table of this, so the Boolean expression for this hex buffer is Q is equals to A. So if we give as a input as 0, so A will be 0, Boolean expression will be 0. And then if we give what A as 1, so it will give 1. But in the NOT gate, it is a invert of this hex buffer, you can see, because the symbol representation of the NOT gate is same as the hex buffer. So but truth table for the NOT gate, before truth table, we'll see the Boolean expression for the NOT gate is A bar. So if we give A as a 0, then it will give the value of what? NOT gate. What it will give? It will give the value of, if it is 0, it will be 1. If it is 1, it will be 0. Because the function of this Boolean expression is Q is equals to A bar. Then, so how many gates we have studied? Totally we have studied the 9 gates. AND gate, OR gate, NAND gate, NOR gate, XOR gate, XNOR gate and NOT gate. Sorry, it is total 7 gates we have studied. So these all gates functions will come under the Boolean functions, where the Boolean function is having the values of variable or a constant Boolean operations. So next will come the how this Boolean function will be how these Boolean functions will be used for the further formulas, which is for your syllabuses. But before that, just will recall till now what we have studied before we go to the further part of this module. Just will see. So starting, we have studied regarding the basics, that is what is a digital system design and what is a digital system and how this digital system is needed and how it is being used in this present scenario that we have seen. And also we have seen the types of digital systems, advantages and disadvantages of these digital systems. Under that we have seen the advantages of analog systems also and disadvantages of analog system, where the analog system will uses the less bandwidth, as we know, and it will be a more accurate. And next, the disadvantage of this analog system is the it is a high cost for the single conversation inside the display. Okay, and it is upgraded digital interface is not possible. Means whatever the upgraded new digital interface is not possible in this analog system. And then we have compared the digital system and with the analog system, or else you can say we have compared the analog signals with digital signals. And then what we have studied next, we have studied regarding the Boolean algebra. So what is a Boolean law? Boolean law, it is a mathematical representation of what you can call operation, that is the values, the Boolean, the function will have the values of variable truth values, that is false and true. It is that is 1 or 0. So after that we have studied regarding the Boolean algebra terminology. So in that we have studied variable and constant and complement and literal, how these all operations will takes place in the logic gates. Also we have seen under the variable, the value will be vary, it may be either it may be a 1 or 0. Then the Boolean function for the variable is y is equals to a plus bc. So So this variable function, the value of these variable functions will depends on the Boolean expressions under the constant. What we have studied, the Boolean expression is ay is equals to a plus 1. So this is a under this constant we have studied that the first term is fixed and the second term may the first term will be vary and the second term it will be fixed. It may be a 1 or it may be a 0 under the constant term. So when it comes to the complementary, so under the complementary, the Boolean expressions we have seen as y is equals to a bar, you can say. So it will be a variable value. When the bar comes, complementary will be represented as a bar on the letter of A. The bar will be there. Then it is known as a complementary. The value of A is, if the value of A is equals to 1, then the A bar of this, or else the complementary of this A, complement of this A, that is equals to 0. So if the A is 0, the complement of A bar is 1. Sometimes this symbol can be, we can represent it as A dash, that is A dash or A bar. So complement can be represented in the form of A dash or A bar. And literal, under the literal, we have studied occurrence of the variables where the Boolean functions either in the complemented or in a uncomplemented form, that is called a literal. For example, the Boolean, not for example, it is a expression for the Boolean is A or A bar. So literal is totally depends on the complement. So after that we have studied regarding the gates. So here I have written the symbols and truth tables of respected gates. Those are AND gate, OR gate, NAND gate, NOR gate, XOR gate, XNOR gate, and NOT gate. So under this, NOT gate will come under the single logic gate. Under this we have studied the hex buffer and NOT gate. So AND gate, it is a combination, NAND gate is a combination of AND gate, and OR gate is a combination of XOR gate, and NOR gate is a combination of XNOR gate. So this till now we have studied these all things. So in the next session we'll continue with the next part with the definition of what you can say Boolean algebras. So in the next session we'll start with the problems and Boolean theorems. And in the, before we start the problems, we'll see the decimal to binary. How we'll convert the decimal to binary and hexadecimal. Before we proceed with any problem, we'll see the conversion of decimal to binary. Thank you.